Alright, hello Math 3 students. Today we're doing 6.2 sign language. So we're using the same Ferris wheel as yesterday, but now instead of just doing certain points like A, B, C, D, E, F, G, we're going to do it based off of time. So we're going to use the fact that the radius is still 25 feet, the center is still 30. Be careful timing observations and realize that one complete revolution every 20 seconds. All right. So if we want to change that to degrees, we know that one revolution equals 360 degrees, right? If you go revolve around once, that's 360 degrees. So if it takes 360 degrees per 20 seconds, if we do that math, we'll get the amount of degrees per 1 second. So 360 divided by 20 should be 18. So I have 18 degrees per second is my rate, or my ratio. Okay. How high will Carlos be 2 seconds after passing position A? Well, if it's 18 degrees per second, multiply that by 2, and we get 36 degrees per 2 seconds. Right? So, hey, look, that's this triangle already drawn for us up here. Here's 36 degrees. So I know that this height is 30 plus 25 sine of 36 degrees. That becomes a calculator problem. 30 plus 25 sine of 36. And we get 44.7 feet. Because we're dealing with feet. All right. So calculate the height and of the rider at each of the following times t, where t represents the number of seconds since the rider. I could have also made this equation 30 plus 25 times the sine of 18 times 2, because we are doing 2 seconds. Okay. Keep track of the regularities you notice and calculate the height. As you calculate each height, plot on the diagram. So we are going to do 1 second. 2 seconds, 2.5, 3, 6, 8, 14.5, 18, 23, 28, 36, 37, and 40. So let's draw it. So 1 second we know is 18. So 18 degrees. So that's 1 second. And this angle has to be 18 degrees. We already did 2 seconds. That's going to be 2 seconds. 2.5 will be somewhere there. Okay, we have to find that angle. Or 2.15.5, so 18 times 2.5. That's 45 degrees. Okay. Then the 2.5, sorry. And then we have 3. So 3 would be splitting that in half right there for 3 seconds. Okay. I need 6 seconds. So 1, 2, 3, 4. There's my 6 second mark. 8. There's 8 seconds. So if all the way around is 20, half is 10. 10 isn't on here. 11, 12, 13, 14. So there's 14.5. 15 will be directly down. 16, 17, there's 18. 20 is all the way back around, so 23 is the same as 3. So that's also 23. Okay. 28 is the same as 8, so that's also 28. 36. So 30, 31, 32, 33, 34, 35, 36 seconds. 37 seconds. And 40 seconds is back at the start there at 40 seconds. So, filling in the chart, I could redo number 2. Number 2 is the exact same. That was 30 plus 25 sine of 18 times 2. And that's how we got the rider height of 44.7 feet. 40 should be 30 feet because 40 is 2 complete rotations. Or revolutions, really. I'm going to use their terminology, revolutions. So back at point A. Okay, so that's how I got 30 for 40. For 1, the calculation is going to be 30 plus 25 sine of 18 times 1, so just sine of 18. 30 plus 25 sine of 18, and I get 37.7 feet. This will be 30 plus 25 sine of 18 times 2.5, which I found was 45 earlier, but I'll just do the math. 30 plus 25 sine of 18 times 2.5, 47.7 feet. 3 seconds is 30 plus 25 sine of 18 times 3. So we get 50.2 feet. So now this changes, okay? So now, if we look at 6 seconds, we're past, if I just draw a line here, that would be 5 seconds at 90 degrees, okay? So if you don't know, circle the side is 0 to the right. If we go counterclockwise, we go 90, then we go 180 degrees. Directly down is 270 degrees, and we're back at 360. So 0 and 360 is the exact same. So if we go past 90 degrees, so now we're looking here at 6 seconds, the triangle becomes here. So the way if we want to use the same exact equation, this angle is 180 minus 18 times 6. Because this angle is 18 times 6, so this has to be 180. That angle is 180 minus 18 times 6. Because 18 times 6 gives me this. 18 times 6 gives me the angle 108. 180 minus 108 gives me this angle of 72 degrees. So I want to keep everything universal or look similar. So I did a calculation here. When we're between, so this is between t is less than 5. So between 0 and 90 degrees. Here we have t is between 5 and 10, so between 90 and 180. 15, so 10 seconds to 15 seconds. So this gap is from 10 to 15. And that's 180 to 270. To 20. So 270 back to 360. So 23 is the similar to t is less than 5. 28 is similar when t is between 5 and 10. Because going after 20, we're recircling again, so this is all the second revolution. All these are the first revolutions. Okay, less than 21st, greater than 22nd. So this means this is when t is between 15 and 20, and this is when t equals 20. So back on the original. Okay, so this equations have to be 30 plus 25 times the sine of 180 minus 18 times 6. So this one is the same as 30 plus 25 sine of 180 minus 18 times 8. So I'll do those two calculations. 30 plus 25 sine of 180 minus 18 times 6. My calculator knows order of operation, so I won't get confused. So that should be 53.8 feet. Okay. And then I'll do 30 plus 25 times the sine of 180 minus 18 times 8. We're back at 44.7 feet. Which makes sense because when we found out yesterday 2 and 8, 2's at B, 8's at E, B and E were the exact same location. Okay, now 14.5. 14.5, we're between 180 and 270, so we have to subtract 30. So we'll do 30 minus. Sorry, I'm flipping through my pages. So this one will be 30 minus 25 sine. But since I'm looking for really, let me make my triangle. I'm looking for this angle. So this angle is 180 plus. 180 plus, or, oh sorry, we're doing this minus 180. So I find this angle. This is 18 times 4.5 minus 180. So I'll take away this 180, I'm back to my short angles. So this one will be 25 times 18 times 14.5 minus 180. So 30 minus 25 sine of 18 times 14.5 minus 180. And I get to 5.3 feet, which is what I want because we're lower, right? We're lower. 18, we're coming slightly back up. So still be minus, and this angle is 360 minus 18 times 18. Because 18 times 20 gets you back to 360, minus the 360, we're back there. So here, this equation is 30 minus 25 times the sine of 360 minus 18 times 18. So 30 minus 25 sine of 360 minus 18 times 18 gives me to 15.3 feet. Now, 23 is the same as 3, so I'm going to put the exact same 25 sine of 18 times 3, and that's 50.2. Okay, 28 is the same as 8, so that's 30 plus 25 sine of 180 minus 18 times 8. So that's the same as 44.7. Now these two are slightly different. So this one would down. So I could follow this equations and do 180 or 360. Since we're using time, they technically say we do 25 minus times the sine. 2 rotations, 360, 540. Nope. 360 plus 360 is 720. And then we have to do that minus 18 times 36. And here would be minus 18 times 37. All right. So here I have 30 minus 25 sine of 720 minus 18 times 36, 6.2. And then 30 minus 25 sine of 720 minus 18 times 37, and we get 9.8. Again, this is technically the second rotation, so technically I have to do the same equation here as 30 plus 25 sine of, I did 18 times 3 because technically this doesn't exist are the exact same locations, but I could really write this, I could rewrite this one as 30 plus 25 sine of 23 times 18 minus 360. And this will be 30 plus 25 sine of 540, because 180 plus 360 is 540, minus 18 times 28. But since I know 28 is the same as 8, and 23 has the same position as 3, I made it slightly easier on myself. All right. So examine your calculations for finding the height of a rider during the first 5 seconds after passing position A. During this time, the angle of rotation is somewhere between 0 and 90. So the general formula there. So the height is 30 plus, because we're going up, right? We're going up 25 sine of 18 times t. And that's all we're doing. The t is seconds. And h of t is height of person. Okay. But now they want to do it for all 4 quadrants. So I kind of listed that out already. We don't have enough room here, so I'm going to try to do my equation for 4 over here. So I'm going to have to do a piecewise function. We're going to have to make our piecewise so that we have, when first copy the first one, 30 plus 25, you know what, I'm losing space. So I'm going to draw it on my whiteboard so you can all see how I'm going to do it. And then from there, I'll recopy it for the late notes later. Okay, so here, my height is going to be a piecewise function. When I have to have when t is between 1 and 5. So that's the 30 plus 25 sine of 18t. We already found that one. Next increment we talked about is 5 to 10. Then we're going to have 10 to 15 and 15 to 20. Notice there are no equal signs. So this one will be when t equals 5. T equals 5 will be the same. When t equals 0, 10, and 20, they're the same. And then when t equals 15, they're separate. So for instance, when t equals 5, we go straight up. So that's 30 plus 25, and that's how I got 55. 0, 10, and 30, we all add 0 at 30. 15, we go down, so that's 5. So between 5 and 10, it's still 30 plus, because we're still going up, because 90 to 180 is above. Right, so we have a circle. Here's my quadrants. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is 0 to 90, or 1 second to 5 seconds. This is 5 to 10 seconds, and this is 180. This is 10 to 15 seconds, and this is 270. And back to 360 at 20 seconds. So that's times 180 minus, right? Yeah, this is 180 minus 18t. Okay, this one will be 30 minus, because now in quadrant 3 we go down. 25, I forgot the sign. Okay, minus 25 sine, but this is time that 18t is bigger than 180, so it's 18t minus 180. And this one, again, is still minus 30 minus 25 sine, but this time 360 is bigger than the angle, so 360 minus 18t. All right, so that is my piecewise function for number 4. All right, thank you for watching. I hope this kind of makes sense of our angulars, because again, we're just going around the circle and we're creating many triangles with the heights, right? So all we're doing is creating our right triangle trigonometry questions and using sine of the angle to find the height. All right, thank you for watching.